Welcome to the last and probably the best session, clearly, of the skills and learning track, apart from Jens, who I know is on the call as well, so I've got to be careful. I think everybody now, given that we're in the last day of the conference, is familiar that you are joining on mute. If you've got any questions, please use chat, and Richard and Frank will plan to answer those as appropriately over the course of the session. Just a reminder, if you can, to provide feedback again, because as we all know, trying to present with to an audience where there is no response whatsoever is somewhat of a challenge. So it's good to get feedback from the audience on how things went. This is session 6BC, so if you can provide feedback on that would be great. So without further ado, I'd like to introduce Richard and Frank, a well-known double act. So I'll pass straight over to these guys to introduce themselves and get on with the session. Richard, all yours.
Very good. Thank you very much, Paul. So hi, everybody. My name is Richard Gamblin. I'm the I'm the EMEA CTO for digital transformation for IBM Z, which means I work with organizations who are asking the kinds of questions that you can see on the chart here, about cloud native development, about containerization, DevOps, API economy, and how they can exploit all of these new and emerging ways of doing things alongside their mainframe applications and data. I am delighted today to be joined by Frank van der Waal.
Hi there. Oh, hi all. So my name indeed is Frank van der Waal. I'm Richard's counterpart in EMEA, more concentrating on the data part when it comes to Z. And we have teamed up in the last couple of years working together. And last year I was more moving into the data part, and we realized that apart from the app story we have, there's also a data story. And that's why we are nicely together, although miles apart, unfortunately, for this year around, or this time around, for the GSE UK.
Very good. Thanks, Frank. So Frank and I have been asked to do this session and talk about some of the terms and the language and the phraseology, the buzzwords that we're starting to hear more and more of now. So we've got cloud native developer up there, we've got DevOps guru, we've got a whole load of industry terms that are coming along, and there is often an assumption that we all know what they are. Okay, and so a lot of this session is trying to explain what they are in context and what they have to do with the technologies that we work with. So when we're talking about a CI/CD pipeline, what does that mean for Kix? There are a lot of tools out there that allow you to do some of these things, but how do they fit together, and what are they designed to do? So over the course of this session, what we're going to do is we're going to have a look at some of the terms and the buzzwords about this way of doing things, this new and emerging way of doing things. So we're going to have a look at that first. We're going to have a look at, well, why are we doing these things? Why is DevOps a good thing to do? Why is container orchestration an important thing? So we're kind of looking at the challenges and the opportunities of how things are working these days. And then I'm going to spend some time looking at the application side of things. So what does this mean for delivering applications, both to ZOS and Linux on Z, but also to cloud environments, either on-prem stuff or public cloud. And then Frank's going to pick up and talk about the data side of this, because so often we talk about these things and we focus almost completely on the applications, but I think one of the hardest things actually is, well, when you're building these applications, they don't work in isolation. They need the data to be able to do whatever it is that they need to do. Okay, so that's the plan for this session. The good news is it is not going to be a 60-minute presentation non-stop session. We're going to leave plenty of time for any discussion, any ideas that you have, any questions or comments. Happily, I do have the chat in front of me, so I'm keeping an eye out for questions or comments. So I'd love to know what you think. Frank, that doesn't apply to you because you have already been asking me some of these questions. So that's this is just for the audience members. So let's dive in, right? So let's have a look at some of these buzzwords, some of these terminology, some of these pieces of terminology. So let's start with the two that sit in the title. So when we talk about a cloud native developer, really we're talking about, as the name kind of says, somebody who is building new applications, new apps, and that are designed to run in a cloud environment. Okay, and that is the simplistic understanding of what a cloud native developer is. Really, what they're trying to do is they're trying to build applications and then package them in such a way that they can deliver them to IBM Cloud, to Azure, to AWS, but they're contained, they're packaged together so that they can be run as a single unit and then potentially combined together with others. So I'm trying to describe that in a way that doesn't start talking about containers and other things, but really it's somebody who is designing applications that can be combined together and delivered on a platform. And the interesting thing is that on the countryside, we've got the DevOps guru. So this is simply a developer who is writing apps and they're employing DevOps practices. And DevOps is all about bringing the developer side of the organization a little bit closer to the operations side. Because historically, what we've seen is an organization will have a developer community who will encode all of the business logic and all of the representation of what the organization needs to do. And then it's kind of thrown over the wall to the operations teams to manage in a live or probably even a pre-prod environment as it starts to be rolled out. And so a DevOps guru is somebody who is employing these practices and procedures that allow you to seamlessly link together the application as it rolls through your development and your test and your pre-prod all the way through to your production environments. And when this session was suggested to us, and somebody said, well, what is the difference between a cloud native developer and somebody that uses DevOps? I was trying to think of an analogy that would describe this, and it's a bit like saying, are we using Zoom at the moment or are we using the internet? Because it was kind of, they're not, you can't separate them. Zoom wouldn't work without the internet. And the internet is, well, the internet's there, but we couldn't talk to each other like this without Zoom. So the two are inextricably linked. And actually what I would say is that a good cloud native developer would be using DevOps practices in order to release their applications. So Frank, sorry, I thought you looked like you had a comment to add there about some of this.
No, I was only admiring your speech, Richard. No, nothing for me to comment.
Okay. So let's get into some of these terms then that we keep hearing over and over again. So we've got them here. So I've got CI/CD, and often you'll hear that CI/CD in terms of a pipeline. We've got shift left, microservices, containers, container orchestration. So I'm going to run through some of these and position them and where they fit. If there are other buzzwords that you want to hear about, put them in the chat and I'll try and answer those. Hopefully I can understand what some of those are, but let's start here and see what we've got. So CI/CD pipeline. So this is our continuous integration, continuous delivery pipeline. So this is basically a massively automated way of delivering applications through each stage of what you're doing. So all the way through from the point at which the developer starts typing out the code to represent, all of the rules and the logic needed for the application to do what it needs to do, all the way through to how it is stored with the repository in the supply chain, in the source code management system, how it's built, created, packaged together, and then how it's delivered and deployed through each of the different environments, whether it's tested, whether it's moved through a staged environment to pre-production, all the way through into a production environment. But the key thing here is it is a very, very automated process for doing this, because actually applications have always gone through some form of this or other, but it's about having a very highly automated way of doing this so that everybody is very clear at what stage the application code is as it starts being rolled out from left to right. The next one on here is shift left. And this is all about starting on the left-hand side when somebody is creating some code, trying to identify as early as possible any potential errors in that code or how two pieces of code are working together. Because if you're building application components and they hit production and there is a problem with them, then you're going to end up with an outage, which is a huge, huge cost. And if you can discover that as you're going through your end-to-end testing, then that saves you kind of the business outage. But actually, the further to the left-hand side of this diagram that you can discover this problem, the cheaper it is to the organization. So if you're working your development environment and you've got some syntax errors, you can if you discover them straight away, you can fix them, right? Imagine it's the annoying thing, you forgot the semicolon on something, or you haven't closed the parenthesis on something. If you can discover that there and then, you don't even have to compile the application, it's done and dusted. So shift left is all about moving from the right-hand side to the left-hand side, the discovery of any issues, any problems, and that saves, in terms of cost, that saves massively in terms of time and also value to the business, how quickly you can get that to production in a high quality way. That's what shift left is. Let's talk a little bit about microservices now. So this is a bit of a buzzword at the moment, because the perspective in the industry is everything has to be microservices. And what this is, it's an application pattern where instead of encoding many different types of functions within one single larger or monolithic application, what we're talking about is a microservice. A single microservice is delivering one or two or a very small number of functions. And the idea is that you can build an environment where all of these pieces can scale independently and can have different levels of security, different levels of access. But also it means that when you start to decompose that huge piece of function into smaller elements, what you can do is you can employ different programming languages that are best suited to the function that capability is trying to perform. So if you think about it, if you're doing number crunching and processor intensive stuff, you want to do something that might be in C, for instance. If you're doing text processing, you might want to use something that's more like a scripting language, like Perl, for instance. And so the idea is that because you're componentizing these, you're able to choose the best language for that function, but then also those components can then scale independently to do that. And the classic example of that is a booking system. You know, you think, well, probably not at the moment, but if you're thinking about booking airline tickets at the moment, you know, somebody checking the price of that is going to be pushing that much harder than probably only the kind of 5 to 10% of people actually booking. Wow, I need to find a different example actually in the current era, but you get the idea, right? You get the idea. So we're starting to see this shift from big monolithic applications towards microservices. Do I think monolithic applications are going to go away? Probably not. Probably not, because there are certain applications that actually are well suited to having all of these very highly rigorously structured components that work together. But this is one of the fastest growing application patterns today. Let's talk a bit about containers now, because this kind of links on from the last piece. So containers are a really nice way of packaging up things like microservices, because if you think about what a microservice is, it's doing one or two things which on their own probably aren't that useful. So we need to combine different microservices and different components together. So you might have a couple of pieces of application logic and then say a Mongo database that goes alongside it to store some of that information. And so what you end up with is the need to bring together lots of different components. And then you need a packaging vehicle to say, look, actually the unit of function, the unit of activity that I want to deliver, we need to package that together. And that is what your container is providing. So probably one of the most common ones that we see today in the market is Docker, but we also see others like Creo, for instance, from Red Hat, that allow you to say, look, I'm going to take my application, I'm going to build it together, package the different components together, and then the container becomes my runtime environment, my executable that I can then deploy in either my public cloud environment, on-prem, on a mainframe. Okay, we'll come back to that piece in a minute, but the idea is that that is the component that you then deploy as your runtime executable. Now, if you think about it, if you're delivering applications that way, you can end up with many thousands and sometimes tens of thousands of containers that provide that business service. And so that's where we kind of come into this need for container orchestration. So the ability to have something that looks at for your whole service, what's the health of all of the application components and containers? What's the health of those containers at runtime? Are they behaving as they should? Are they scaling enough to meet the demands of the requests that are flowing into them? So do we need to scale up additional container components? Do we scale them back? Do we need to, stop some of them? And so on and so forth. So the container orchestration components would be things like Kubernetes is one technology, for instance, that allow you to orchestrate many different containers. So just a few things there on terms and buzzwords. I haven't seen any others come in on the chat. I just realized actually, this is still very application focused. Frank, I don't know if you had any data buzzwords that have cropped up that you've picked up on that would be good to explain.
Well, in the whole data area, of course, it's so much focus now on AI and on that kind of high level stuff. What is interesting, of course, to see, but also to realize that when you're talking about microservice and data, you get this interesting view of discussions where is the data in a microservices environment, and how does they relate from a data flow point of view, right? That was wonderful. If you have a wonderful a big monolithic application only talking to DB2 for ZOS, you don't have to worry about the freshness of the data or thing, because it's in one monolith. Now with microservices, there's somewhere a tip point where you say, well, this is too many microservices to flow data through. Where is the data? What's the freshness of the data? How you do all that? So there is a kind of a tipping point. What I always like to express, that if you really think about an artificial intelligence way of thinking, where companies, of course, are heading to, you can do an artificial intelligence without an information architecture. So you can't do AI without IA, and IA being information architecture. So you have to really think also on the data level, apart from the application level. That might be always very handy to have completely microservice approach, but it's not always true. I mean, like you already said, Richard, will they go away in a very short time? Probably not. But also, I think from a data angle, we might say step back sometimes and okay, is this what we really want? So for me, the path to AI, where customers are really seeing the benefit, the business benefit of it, should be underpinned not only by the application part but also by the data part.
Okay. So these are some of the terms that we see. Let's talk about this in terms of some of the challenge and some of the opportunity, because if we think about the application landscape today, what we have is an environment where on one side you've got a very traditional way of mainframe and ZOS applications being delivered. So these are the traditional monolithic applications, COBOL, PL1, highly structured data, whether that's in DB2 or IMS or VSAM or wherever it may reside. And this is the kind of traditional way of doing things, versus on the left-hand side of the house, where you've got this containerized, cloud orchestrated microservices world going on. It means that there is real friction at this point here, because the way that things are being done on the left, or have historically been done on the left, compared to how they're done on the right, is very, very different. But things are starting to change, right? And it becomes a very interesting place when you can start to say, well, what happens if we have the ability to quickly and speedily deliver applications to any platform, and you can exploit the benefits of the underlying infrastructure. So in public cloud, for instance, you might want to put your applications that actually you don't know how much they need to scale. So actually they might want to scale once a year or once a month from nothing to all out everything. And so there are some ideal, public cloud environments, a huge benefit for doing that. Likewise, if you have particular security requirements and need to embed some of those security characteristics that are really only uniquely available with mainframe technology, then you would want to host those here. And so we need to remove this layer of friction between the two. And actually, you start to see that already, right? Because we know that on the platform now, we can deliver Java applications. We know that we can deliver things like Spring Boot applications, Python scripting components, Node applications, and now even Docker on ZOS as well. So those barriers are already starting to break down. But I think that the real opportunity here is to say, well, look, if you think about being able to deliver applications through this DevOps pipeline, this highly automated way of delivering applications, it no longer applies to just the microservices and the cloud native world that sits out here on the left. But actually all of the practices and procedures and now the tooling as well, and we'll come on to that in a moment, allows you to deliver applications over here on the right hand side on ZOS. They've been able to do that for quite a long time on Linux on Z, but the ability to follow this process and deliver them on ZOS now is very powerful, using the common tool chain, the common practices to be able to do so. And that's not just the Node applications or the Java applications, but the real COBOL applications in say a Kix environment. And this is proving very powerful. And of course, we're now at that tip, and we've been able to do this for a number of years, and we've got organizations that have done this for kind of 5-6 years now, and for whom this is very mature. But what is starting to change now is this ability to extend that cloud orchestration layer and say, well, actually, we now have a management framework that is not just looking at the health and also the delivery of applications over here, but also the ability to stand up the monolithic application patterns, a combination of say MQ, IMS, and DB2 over here on the right-hand side, to be able to say, well, actually, I just want to stand up my service, and I don't want to have bespoke ZOS skills and knowledge to be able to do that. I can now stand up for the consumer over here, the end-to-end service across the board in a single common framework under that single cloud orchestration, and we can do that now. Okay, and that's something that is available in the last couple of years, and organizations are starting to embrace more and more. And we see that, right? We see that evolution over time from this cloud native world over here way of doing things that is fast growing, and we're going to see that extend across to the mainframe as well. And you can see that here. So you've got the traditional applications below the chart here, and the cloud native way of delivering applications. And you can see the traditional way of delivering applications tailing off, and the cloud native way growing here. And this will change over time, probably over the next 10 to 15 years. We will see more and more applications being containerized. We'll see more and more being delivered as microservices components. And by the way, they will be delivered on Z as well. They're already being delivered on Linux on Z, but they will be delivered on ZOS as microservices components that are being containerized and are managed through that cloud orchestration framework. Okay, and so this is the real opportunity here, because it means, let me go back a moment, it means that when you deliver an application, you can choose whether you want to deliver it to public cloud or private cloud or on your ZOS environment as quickly, as easily as any other platform. And so you start to say, well, what I want to do is encode this, I want to encode this business function in the language of my choice, using a skill set for delivering an application that is true across all platforms. And actually, I've decided, you know what, it needs that proximity to the data, or it needs that security characteristic, so I'm going to deliver it over here. Oh, actually, I've got this other element of the microservice that needs to massively scale independently of everything else, so I'm going to deploy that in public cloud. And so it's that freedom that gives us huge opportunity about how we can deliver enterprise applications in future. So let's take a little bit of time now and just focus on the application. So I'll talk a little bit about the application, and then Frank's going to talk about what we're doing with data. So when we talk about bringing this cloud native concept to Z, and really this is ZOS I'm talking about here, because from a Linux on Z perspective, You know, that is Red Hat or Ubuntu or SUSE. You know, that's a platform that is already open as a Linux-based platform to doing many of these things, and that has been done for some time. Really, what I'm talking about is that cloud-native developer experience for the ZOS environment. And really what we're talking about here is saying, look, we have delivered applications to ZOS in a way that is completely different from anything that is contemporary or seen to be contemporary today, whether that is the practices that you're using, the processes, the procedures, all the way through to the tooling. And you know, if you're building applications on ZOS today, there is no good reason to use green screen green screen development tools, ISPF panels to look at that COBOL code. You know, whether I know there's a bit of a religious divide at the moment between Eclipse-based tools or Web UI-based tools. Doesn't matter. Whatever your tools of choice are, you should be allowed to. You should be free to use them with whatever whatever target platform you want to build to. And you can see some of the tooling that's listed here. And I'll come back to that and look at where they fit together and how they relate to the ZOS environment. But the idea is that you have this cross-platform set of tools and practices and capabilities. And what you're trying to do is you're trying to accelerate the speed at which you're delivering applications. So push things faster, to have extreme levels of automation and control about how you deliver that application, all the way through from I've got a blank screen and a blank framework that I'm building my application to, all the way through to that production environment on the right-hand side of the diagram that we've seen. But to do that without sacrificing quality, because anybody can start doing things faster, but mistakes will creep in. And so it's about saying, well, how do we work more effectively? So how do Frank and I work on the same piece of code? You know, historically, we've never been able to do that because I might have changed something and added a load of variable names that Frank hadn't, or had decided to add further on. And so, there'd be conflict. So the tooling is there now to allow us to do things like parallel development, to check when you forked that piece of code, and as you bring it back together, it identifies all of those potential concerns. And all the way through that extreme level of automation helps with doing those kinds of things. So if we step forward, I'm going to hold my hands up here and confess that I cheated slightly because yes, we want to deliver high quality applications at speed, but our delivery process, our CI/CD pipeline, doesn't actually just flow from left to right. It actually looks a little bit like this, or it should do. Okay, it should look like a cycle where in the diagram before we started with coding, and I think we probably released to production on the far right hand side. But the reality is we may be starting with the coding piece and build and provision and deploy. But at each stage, you need to have that ability to loop back round again in shorter cycles. And this kind of illustrates that shift left, because if you're coding something and you'll build it and there are problems with the build step, then you want to go back and say, okay, that was something in my code that caused that to fail. Similarly, as you provision and deploy and do so more quickly, as you test it, the sooner that you can test it and get the feedback back to the developer who can make those changes, rectify any issues, the better. And then as you go around the cycle, as you test it, as you release it to your different environments, clearly you want to, you need a measurement step to say, well, how is it performing? Just because it functionally works doesn't mean it's performing well. So you need to understand, let's monitor that. It's, the performance might be awful, so let's do something about that. And then, of course, what you want to do is, rather than just go and have an argument with your developer, which I've seen people do, you want to say, okay, well, let's feed this back into the plan of the next iteration. And we don't want the next iteration to be 3 months down the line. We want to do it in such a way, because this is so highly automated, we want to do that in such a way that actually it pops up as a priority on this developer's workstation to do something in the next matter of hours or days. And we see that with smartphones. We see how quickly the new app releases come. And actually, if you look at what they are, they're almost entirely bug fixes, tweaks, glitches, excuse me, that are being fixed. Because ultimately they're trying to deliver that user experience that's more refined and more frictionless. And that's really what we're trying to do here. So we monitor these things, we plan for the next iteration, we do some analysis. Maybe there may be some new requirements, there may be some fixes from the last time, and then we feed that in, and all of the approval steps where necessary go into that. And of course, there are a lot of different ways of doing this. There are a lot of different pieces of tooling that allow you to do this. So this chart's just going to build up and show how we do it. But the thing that I like about this chart is that it illustrates that whatever your tool of choice is in your organization, whatever as an independent developer, whatever your toolkit is of choice, that the idea is that you can bring that and start delivering your applications, packaged or otherwise, and start delivering those applications to ZOS in a familiar way. And then in some cases, we extend that capability with specific things that allow you to bridge to what ZOS is doing. So for instance, you might have dependency-based build. So if you're doing a build step of your application, some of these components aren't going to know some of the nuances of what ZOS is providing. So DBB, for instance, provides that extension to allow you to step in and say, oh, by the way, when we're saying build and green checkbox, or the box goes green, then under the covers, what's happening is DBB is being kicked off to be able to build that in a ZOS environment. And we see that all the way through here. We see this all the way around, both across the top from coding to test, and all the way back across the bottom through release analysis, and away you go. And it's very interesting. A friend of mine, for instance, does all of the development he does is .NET code. And the stuff that he does, he uses VS Code to do all of that. That's his developer environment. If he ever wanted to start going and building Java components, he would want to use VS Code to be able to do that. He wouldn't want to have to start looking at Java code through ISPF, for instance. But he can take those tools that he's familiar with and start building out his code components and actually follow all of this. And deliver application code to ZOS without ever having to worry that it's a ZOS target that his application is being deployed to. So it's a very powerful way of looking at it. It's a nice way to say, look, we can deliver applications in this way to an environment like ZOS that has historically not really looked or felt like a best practice DevOps pipeline, or something that's familiar to a cloud native developer. So I'm going to stop there, because all of the stuff that I've talked about has been about the application delivery, and so often we focus almost entirely on the applications. But working with Frank in the last couple of months, I've realized that actually those applications aren't going to work if you don't have access to the data, or there are so many problems with being able to get the right pieces of data at the right time that we really struggle. So I think at this point, Frank, I'm going to hand it over to you, and you can take us through the data part of the story.
Okay, thank you, Richard. And let me get this one on. And so where are we? We were about here. So yes, it is interesting, and only to come back to your story, and it just reminded me that last year around this time frame, I think we have the GSC in the Netherlands, always 2 weeks later than the one in the UK, and together with the team of Jen Francis, who is on the call here as well, I had this idea of how would it be if we have 25 students out of a high school who doesn't have any experience with ZOS whatsoever, to drag them in, put them in a room, basically lock the door, throw away the key, and at the end of the day they could only escape if they came up with an application running on ZOS, but using their tools. So yeah, it actually works. So those 25 students, they're divided in groups. Only one group, because they were looking at other sessions during the GSC, didn't make it, but the other groups created just a Node.js application. I mean, it would be silly to think that they were completely COBOL Kix developers in one single day, but bringing their own tools, bringing their own tool sets, using Kix catalog manager, and APIs to it, they created something that runs on ZOS. So you can see from a skills perspective they don't care as long as they don't have to look at silly 3270 ISPF panels, etc. So that always reminded me and always triggered me. So, well, it is possible. People are shouting us to IBM about skills, but it's also an internal thing. And I'm pretty sure that Jen will be able to guide you along if you have any questions of how to build skills in a company, but also from a company to new hires or to universities. We can do wonders with them together. Okay, so now concentrating about the data, because exactly what Richard was saying, that the application flow is not easy but doable. But it's interesting to pick up Richard's flow and to see where data pops up. And basically you realize that in every single stage, there's a data element in it. And if you create an application or you have to change an application that doesn't actually touch the schemas of a DB2 for ZOS, for example, then you can do data. Of course, you have to have test data, you have to anonymize it, and all that kind of stuff. But it's a different story if from day one the developer needs to change something also on the DB2 part, and it is also a skill item, because an app developer, and if I just listed that in 3 bullets, what their ideas and skills and responsibilities are. They have to drive, in the case of a Z, the integration of the overall DevOps architecture with all the hubs, etc. They probably demand the tool sets if it's a DevOps architect kind of role. They focus very much on the process steps, etc., and hope to get the proper tooling. Whereas if data is concerned, there's also a DBA, the database administrator. And they have different skills and also different responsibilities. The DBAs are sometimes they're basically enforcing business rules to basically reduce operational issues. They don't want to be called up in the middle of the night that a lock is on a database or that an application can't find the database anymore. So they have the tendency to be a bit more change aversive. So they don't like the change. Whereas the app developer, his or her only task is to change things. So you can see that they are a bit colliding with each other. And of course, the DevOps process frequently does not focus on database changes. For a DevOps, and that's the way it is, they want to change code. And by the way, it's handy to have an extra column in the database. So why is that different than to create another variable? Well, the DBA can tell you why, but the DevOps person doesn't really care. So you can see here a conflict of skills and responsibilities in one single organization. Going to the pain points that application developer waits sometimes, frequently by the way, I will show you in a couple of slides, for the DBA to make those changes. How difficult can it be to add one column in a database? What are we talking about? Well, it has to apply to all kind of rules. So the pain point from an application development is basically waiting and etc. And especially when it comes to Z, because then Z is the platform that is difficult and that is not flexible, and you have to wait, etc., etc. Whereas if you see the pain points from the DBA point, he just has a couple of things. Basically, he wants to keep his environment as pristine as possible, because he then knows I don't have any issues. I don't have to call up in the middle of the night. So what we see in larger organizations, and if you are far-fetched in your organization, it might be different, but we see in many organizations that the DBA is just trying to run his systems, and there is a kind of an email or Slack or whatever kind of thing for monitoring all kind of tickets that are coming there. And they are often simple changes of the DDLs or the schemas of the DB2 environment. He then or she needs to do that manually, which is not always the best thing. I mean, there are many DBAs. The one might do it slightly different. One might say, okay, I like this kind of column name or this DB2 the table name that you create, where it might not be completely up to standards, etc. Security is always an issue. But basically what we are saying, it takes time. And the DBA is king of the hill in this case, whether he can stop or let things go. Put in a kind of the flow chart where Richard was referring to. Also from a data perspective, we see on those hubs many places where there is waste in the sense of time. Because it takes time, and we have seen, we have done studies that it can up to even months in the whole cycle that we have been waiting, or that one developer group is waiting for the DBA group to do some requests. And apart from that, that it's time and it takes resources, it also lacks the ability for quality. Like Richard pointed out, the shift left part, it's good to make sure that whenever you make a buggy piece of code, the sooner you will realize it's buggy, the cheaper it is. But and the higher the quality on the end will be. In the database part, it's exactly the same. If you can early detect that this change is not good, or it is good, then you save time and you only enlarge the quality at the end of the show. Put it in a more animation flow. This is what we see happening. So we have this developer, a young and bright girl, and she starts coding away, and she realized, I need a database schema change. Typically what happens is that she mails or slacks or phone this database administrator guy, who then has his book of rules. This is my business rules. This is how we name things. This is how we implement things. And then he has to see if that requested DDL change will match his book of rules. That might be a 10-minute job, but the problem is he has 1,000 10-minute jobs at this moment. So you see that there's a lack of time. And whereas the developer who wants to develop, so well, okay, I can already continue with my code. So she might be already in version 2.3 or 1.7, I don't know where. And she said, well, I don't, the database thing that is still processing, but I can already go ahead. But of course that's dangerous, because after a couple of days or weeks, the database administrator, you're good to go, all set. But then you might come up in the situation that the schemas and the DDLs are out of sync with code version 2.3. And that might not be always very easy to test or easy to see. At least we've seen things that then an application starts to go rogue and an application error. And then what's left is that the developer will call the database administrator in the middle of the night, probably, because then this bad job suddenly went south, and terrible things are happening. Whereas we see that looking at the tools, but also the DevOps pipeline that Richard created and discussed with us, it would be a wonderful situation that on the one hand side, you still have the DBA with this book of rules. You have this developer, but now the developer is not only the coding, but also she, in this case, can do a DDL change. But they push them together to the source control management system, whether that's that GitHub or any other thing. And she just can create a pull request from both the code as well as the DDL change. And that integrated in the pipeline method. The database administrator doesn't necessarily have to do it manual, but he just coded his rules into the pipeline method. And from there on, there's a approve, a decline, or a rework. Let's assume it's an approve. That's done in minutes. And it automatically merges with the master brand. So you can clearly see, although perhaps not all DBAs might like it, it is a much cleaner process. And the skills needed on the DevOps side, they don't change too much. Whether if you code a bit of if you push a piece of code or a DDL, which is also probably in code, in COBOL, for example, it doesn't really matter. And the only thing now left is that this developer is calling the DBA, and you can hear the violence coming in because, well, everything works okay and they will go out for dinner, etc. Oh, that's not allowed. After the lockdown, they will go out and have a nice meal together. So you can clearly see that from a skills perspective, the developer and the DBA are going to be more in line with each other. And now you can see that the whole cycle will become much shorter. Well, this is more a kind of a chart where we think that the tooling that is, and it's called, by the way, IBM DB2 DevOps Experience, doesn't roll easily off from the tongue, but that's the way it is. It's not so much about the products, but you can see that from a line of business point of view, this person is really to bring applications to the market faster with a higher quality. The architect is the guy or the girl in this case that built that integrated DevOps team. But the DBA for ZOS, the app team, and the release engineer, they can all do things faster. And from a skills perspective, for them it's basically the same, because you use kind of the same tools and the same kind of pipeline to make that all happen. So. Last slide for us. I think not the last slide, but we covered a couple of things. We covered a lot of terms today. We have covered DevOps. We covered cloud native, CI/CD pipeline. Again, not only applications but also from a data point of view. We covered shift left, container orchestrations. Again, for me it is, from a data point of view, it's very interesting to have discussions. How about those microservices and how data will be flown, and how intrinsic data is and how unique data is. You want to keep a transaction, of course, as a single unit of work, and that kind of discussions might pop up. But also perhaps a couple of terms that you would like to either have covered or perhaps add to this discussion. So for me, please, I lost my chat window while I'm presenting. Don't know where they are. But probably Richard is monitoring them.
I am. Yes, there haven't been any questions yet, but maybe there are. So I think this is everything that we wanted to cover. And so if there are any questions, please feel free to put them in the chat. Paul, perhaps we could invite you back as the chair, so that if anyone wants to ask questions by voice, the old-fashioned way, then they can do.
Yeah, if there's anybody who'd like to ask a question or just want to make a point, let me know and I will unmute you. But you're right, Richard, there are no questions at the moment. I think that's just underlines how clear the presentation was and the information you shared. And I think this will be a really useful asset for those people who maybe couldn't join this one because it clashes with other topics at this time.
Yeah, and thank you for putting up that session feedback chart, Frank. That's good. I see somebody has suggested some numbers. So I've just realised actually they've put it all to the right. I think they should have all been. Oh no, there we go. Yeah, there have been some suggestions there.
I can't imagine who would possibly have put those in to encourage the audience. Fantastic. Okay, it looks like no questions and nobody I can see wants to add anything further. So I think we're done for this session. Thank you both for giving your time. I think this was very interesting and informative. And as I said, I think it'd be a useful asset which a lot of people will go back to after the conference is over. So many thanks to both of you.
Okay, welcome.
Thank you very much.
Okay.
Thank you guys. It's now lunch for anybody who's not already had it.
Okay, take care.
Thanks, Richard. Thanks, Frank.
Bye-bye.